everyone, my name is Wiegreffe, and today I'm going to be presenting our work titled Reframing Human-AI Collaboration for Generating Free Text Explanations. The motivation for this work is as follows. The current dominant learning paradigm for training a free text explanation generator is supervision on human-written explanation datasets. However, such datasets are difficult to collect and quite expensive. Additionally, training large models or fine-tuning large pre-trained models has become increasingly inaccessible and burdensome to the average NLP researcher. Which leads us to ask the following question. Are these human-written explanation datasets needed for supervision? Or can large language models explain their predictions given only a few examples? We have two main contributions. We first demonstrate that few-shot free text explanation generation is competitive with crowdsourced datasets. Secondly, we propose a cheap, binary, human judgment-based filtering method that actually can improve over GPT-3's explanation quality. We prime GPT-3 on instances from the Stanford Natural Language Inference and Common Sense QA dataset. The first step in generating few-shot explanations from GPT-3 is to collect predictions from the system. We input some number of training examples with a gold label as well as a human-written explanation written by either ourselves, the authors, or from the crowdsourced datasets. After some number of randomly selected training examples, usually 8 to 24, we append a test instance where we leave the input blank after the word why, conditioning the model to generate an explanation. Our first question is whether GPT-3 generated explanations are preferable to crowdsourced ones in existing datasets. We find that when we condition on high-quality author-written explanations in the prompts, GPT-3 generated explanations are often judged to be on par with those in existing crowdsourced datasets. This demonstrates the feasibility of using large language models for automatically creating free text explanation corpora. But are annotators simply selecting preferred explanations on service-level features like factuality or grammaticality? We look into the fine-grained aspects of preferences for GPT-3 explanations. We see that GPT-3 explanations are rated statistically significantly higher in surface-level features such as grammaticality, generality, and factuality. But they have room to improve in important areas like introducing new information, supporting the label, and overall acceptability in the case of SNLI. How can we improve upon our fine-grained results? We revisit our use of greedy decoding under the strictest evaluation setting, that all 3 out of 3 annotators find an explanation to be acceptable. Simply adding 4 sampled explanations to the greedy explanation to produce a set of 5 greatly increases the number of instances that have at least one explanation that is acceptable at the strictest level. However, GPT-3 knows nothing about human explanation preferences that a larger corpus can provide. So we reframe the role of our human annotators, whom we no longer need to write explanations for the dataset, by collecting 5,000 binary judgments of explanation acceptability. An overview of our pipeline method is as follows. We begin by overgenerating explanation candidates by taking 1 greedy sample and 4 stochastic samples from GPT-3 for each instance in our training data. We then collect crowdworker acceptability labels, 3 per, indicating binary acceptability of each explanation. We then train a T5 and T0 based filter model on this binary classification objective. Finally, the model produces a set of predictions for each explanation. And we have 2 evaluation settings. In the first, we select the top scored explanation. We additionally perform evaluation at the explanation level, which is reminiscent of a setting in which we would like to provide the set of all acceptable explanations to a group of human end users. We validate that our classifier model works well and that larger model sizes results in higher performance. Here we can see that our T0 3 billion filter, which was our best performing, outperforms the baseline significantly, and crucially, outperforms an explanation-only baseline, indicating that it is not simply modeling spurious features of the explanations themselves. Finally, the takeaways from this project are threefold. We demonstrate that GPT-3 shows the potential to automatically create free text explanation datasets that have comparable levels of human acceptability to crowdsourced datasets. We demonstrate that GPT-3 explanations' human acceptability can be further improved with expert-written prompts and a trained filter model operating on model overgenerations. And finally, despite its subjectivity, crowd worker acceptability can be modeled, and is not only explained by surface-level features. Thanks.